Problem 2, section 3-4. I have 5 different limits at infinities. We need to compute. Okay. We want to look for horizontal asymptotes. Horizontal asymptotes means limits at infinity exist or the limit at negative infinity exists. Okay. What does that mean? Either positive infinity limit or the negative infinity limit should give you some real number. So that will fetch you horizontal asymptotes. So let's go through one example at a time. My first example is negative 6x over 5 plus 2x. I'm taking limit as x approaches positive infinity. I've started here. Limit x approaching infinity, negative 6x over 5 plus 2x. This is a rational function, that is a polynomial over a polynomial. That is what is called a rational function. So in limits to infinity or negative infinity, the way you approach for a rational function is you divide the numerator and denominator by the highest power of x of the denominator. All right. Look at the denominator. I have 5 plus 2x. So the highest power of x is just x to the first power. So I'm going to divide the numerator and the denominator, all of the denominator, by x. I hope it's clear, right? Highest power of x is x to the power 1, which is just x. So I'm going to divide the numerator and denominator by x. All right. So limit x approaching infinity, negative 6x over 5 plus 2x is limit x approaching infinity, numerator divided by x, denominator divided by x. All right. So what happens? Division distributes. So negative 6x over x is simply negative 6. Whereas here, division distributes. X goes to 5, x goes to 2x. So I get 5 over x plus 2x over x gives me just a 2. Now, as x approaches infinity, I can take the limit upstairs and downstairs. So I've taken this limit to negative 6, taken this limit to each of the pieces downstairs. Okay. Once I do that, upstairs, mind you, this is a constant. It is not affected by what x does. So I get negative 6 here. All right. Upstairs is negative 6. On the denominator though, if you saw my video on the theory, 5 over x, as x approaches infinity, this gets me 0. Okay. If you don't understand it, go through my lecture slides or the video on my lecture slides. You will see explanation to that. Any number over x as x approaches infinity, that gives me 0. Whereas this gives me 2 because 2 is a constant. It is unaffected by x. So what remains? Negative 6 upstairs. And this is 0, gives me nothing, plus 2. Negative 6 over 2 is negative 3. All right. So I'll put in negative 3 and wait. Now the second question. 12x minus 7 over x cubed plus 2x minus 15. X approaches negative infinity. Okay. Again, this is a polynomial over polynomial. So it is a rational function. You have to divide the numerator and the denominator by the highest power of x in the denominator. The denominator highest power of x is x to the power 3, x cubed. That's the quantity you want to divide the numerator and denominator by. So this limit is equal to limit x approaching negative infinity, 12x minus 7 over x cubed plus 2x minus 15 over x cubed. All right. Now, division distributes. So you have 12x over x cubed, 12 over x squared, 7 over x cubed, 7 over x cubed. Here, downstairs, x cubed over x cubed is a 1. 2x over x cubed is 2 over x squared. Minus 15 over x cubed is minus 15 over x cubed. Now let x go to negative infinity. Well, as x goes to infinity or negative infinity, denominator gets larger and larger and larger. So 12 over x squared is 0. 17 over x cubed is 0. 1 is unaffected. 2 over x squared is 0. 15 over x cubed is 0. 0 minus 0, 0. All of this in the denominator, 1. 0 over 1 is a 0. Alright. Next, x squared minus 14x minus 10 over 6 minus 8x squared. Okay. Limit x approaching, where am I? X approaching positive infinity. X approaching positive infinity. X squared minus 14x minus 10 over 6 minus 8x squared. Again, this is a rational function. Polynomial over polynomial. Divide the numerator and divide the denominator by the highest power of x you find downstairs. Highest power of x I find here is x squared. So, take the numerator, divide by x squared. Take the denominator, divide by x squared. Distribute. So, x squared over x squared is a 1. 14x over x squared is 14 over x. 10 over x squared is 10 over x squared. I hope it's clear. So, look, 14x over x squared, one of the x's cancel. That's why it's 14 over x. Likewise, in the denominator, 6 over x squared, 8x squared over x squared is 8. Now, as x approaches infinity, each of these denominators get larger and larger. So, these fractions disappear. 14 over x will tend to 0. 10 over x squared will approach 0. 6 over x squared will approach 0. What survives upstairs? 1. What survives downstairs? Don't forget, negative 8. So overall, it is a negative 1 over 8. Next, these two are radical functions. I need more time to explain it, so I'll continue this video, okay, for the second problem.